Hello, I'm Yusuf, and by looking at the title of this video, I'll be talking about image segmentation, and I'll show an image segmentation demo using MATLAB and some of its built-in functionality. The code will be available in my WordPress site in the description below. So yeah, hopefully by the end of this you'll understand what image segmentation is, be more familiar with MATLAB and its built-in functionalities, and process images to your own needs. So what's image segmentation? What's the purpose of image segmentation? It's basically an initial step in a series of processes to extract or understand the overall image. So you're trying to make a pattern of something in the image. For example, we've got a horse rider image here, and by looking at it, you can tell there are at least like 3 elements in the image. We've got the horse, the rider, and the background, and these are all classified in the image next to it. There are many types of image segmentation. Here, for example, we've got a bike rider. We're using the same concept as the horse rider, but with labels. So you can guess it. There's a bike, there's a rider, and then there's the background, and then they're labeled. And this method is mainly used for classification, as shown. Another type is to extract an image from its background. So we've got a kitten here and a grass background. Extracting it would basically just cut out the cat or the kitten from the image. There are many more techniques, but in this video I'll just be focused on some concepts using MATLAB and walk you through the code and the thought process of it. So say you were given a task, you were given this image and you're asked to identify the values using image segmentation. Now, obviously you can tell the values by looking at it, but I just flipped them for convenience. So the method should still work for flipped coins. Now, by looking at the image, what are the common characteristics that you can see at first glance? They're circular, so we can use that to our advantage. We've got a pattern here. They also got a consistent background, so just black background. So it's always easier to work with consistent backgrounds because the more colors, the more noises in the image, and then the more work you need to do to actually implement something. So yeah, that's good. Let's just use that to our advantage. Now next, so in image processing, it's always easier to work with black and white images, right? And to understand why, I'll just walk you through a concept. So all images consist of a number of X and Y pixels, and each pixel contains 3 channels, RGB, so red, green, and blue. And the color of that pixel is determined by the number or the range of intensity of each of the channels. So an intensity in red with an intensity in green and with another intensity of blue will make a color. And that's what's shown in this example here. So you're always dealing with the image itself times 3, which are obviously three layers in one pixel. So it's always easier to work with less layers. So to transform the image into black and white, that will just make the process easier for us. Now, I would go with grayscale, but then grayscale still got 3 layers because we've got the gray, black, and white. So we're still dealing with a noisy picture basically. So what we do in image segmentation is binarize the image, convert the image into only ones and zeros, so no intensities, no RGB colors, just black, pure black and pure white, as shown here. Now what I would do next is fill the holes, make it look more cleaner, such as this here, and then clean the image, fill in the tiny little white scratches here and there, and that would be the output. So then I would need to extract the 7 coins. So we've got 7 coins here. I need to extract them to work with each one individually so that I can actually identify them. So something like coin 1, coin 2, coin 3, coin 4, coin 5, coin 6, and coin 7. Now we're almost done here. So you know that a euro, a coin of a value of €1, always has the same diameter. So it's always consistent. And there's no value that has the same diameter as another value. So they're all unique. So we can use that to our advantage and figure out or identify the value of that coin using its diameter. So something like this, highlight the image or highlight the coins and then use some MATLAB functionalities to detect the diameter and then identify it that way. And now I'll just walk you through the code of how I've done it. Now here's my code. So I'm taking the original image, yeah, and I'm just reading it and showing it. That's all I'm doing here. Next, I'm converting it to grayscale because you can usually convert it directly from RGB to grayscale, but the RGB to grayscale converts it to gray, and then you would want to binarize that. So IM2B does that for you. So that will be the output. This here is the threshold, so it's just specifying at what threshold. So below that threshold, all numbers are going to go to 0, and above that threshold, all numbers are going to go to 1. So you can just keep experimenting with that until you get a good looking image, I'd say. And and then I'm filling the circle with a function called imfill. That basically takes the binary image and fills all the holes in it. So as shown here, I just cleaned the image. Now I'm trying to clean the noise on the background. There's a function called trell. It's a structuring element that cleans the image, yeah. So it takes an argument. In my case, I use disk. There are plenty of shapes. Let's actually look at the documentation together. So you've got shell here, it's a morphological structuring element. Morphology is basically the study of shapes, so you can do anything with that. MATLAB is really powerful when it comes to image segmentation. So you can pick whatever shape you want to fill the image with, and then specify the radius. And that's what I'm doing here. 30 turns out to be perfect for me, so that's what I used. You can still experiment. The code is in my description. Now from this noisy image, I transformed it into this clean image. And then there's a BW label function, and that function extracts. So it looks at an image and sees a pattern, and it extracts all of the coins into a separate image. So by using this line of code here, and I can go through all the 7 coins. So that's coin 2, that's coin 3, that's coin 4, etc. Now if you go for the max label, which is your BW label here, that will show you the number of labels in an image. Let's say you've got more than 7 and you're just too lazy to count, so you can just use that and figure out the number of labels, which is here 7. Now next, I would want to extract data from the image. So I would want to extract the diameter of every circle, every coin basically. Now region drops the function that extracts shapes or regions from the image. If we go through the documentation here, it measures properties of images. You can measure a bunch of things if you just go through the documentation. it's really easy to use. So you do region props and then table and then label, and then you specify what you want to measure. So that creates a label of all the diameters. And then I've used that label to actually connect it to the the coin itself. That's why I had them flipped over, just to connect them to each other. And then I'm using this simple, very simple if-else statements to identify the coins. So I'm going through all the labels as shown above, and then I'm using the diameter. I'm making sure the diameter is in a certain range, and that means if it's above or greater than 749 and less than 759, that's a euro. So that's how I classified them. And then I'm show pair, which overlaps the two images and shows you which and highlights the coin in question, and it just gives it a title with the amount set up here. Now an extra thing you can do is just use the radius and the centroid of a circle to actually draw a circle around them. So here in this piece of code, that's what I'm doing. And yeah, that's all really. You can take my code and just play around with it. And yeah, I hope you enjoyed this. Thanks for listening.